Hello, Betties. Welcome back to another episode of Better with Dr. Stephanie. It's me, your host, Dr. Stephanie Estima. And today I am bringing you a conversation with Dr. Don Layman. He is the OG on proteins and amino acids. So get ready for a masterclass on that.
I think we all start with muscle and we think about mobility and we think about athletes. But certainly as we get older, our functional mobility is a big issue. I always like to, make people aware that, for people who get beyond 60, 65, one of the major problems with long-term health is falls and breaking, fractures and things. There are 300,000 hip fractures per year in the United States, and 1/3 of those people never leave the hospital. So mobility and becoming more frail and all that is a major issue for keeping muscles healthy. So that's certainly part of it. And related to that, I think one of the things people don't understand is that we're continuously rebuilding our muscle proteins. Every protein in the body has a finite lifetime, and we have to make somewhere between 250 and 300 grams of new protein per day. And so people think, well, I'm eating 65 or 100 or 165 grams of protein, but I still have to make 300. So that sort of says, metabolism is more complex than just, I eat 100 grams of protein and therefore I make 100. I mean, that's not how it works. So, I think that whole process is critical. That leads us into the metabolism. Muscle makes up, somewhere around 45% of our body weight and a huge amount of protein. It's very involved in each of the macronutrients. So protein, carbohydrate, and fat are all heavily metabolized there. And I think it's important that we think about each of them. Just from a standpoint of protein, since I started with that, we're making 250, 300 grams of protein per day. Only about 25% of that actually goes to muscle. The rest of it's for organs. And the organs always have a first priority. And so muscle is sort of the second priority at a meal. And that's why the meals become very important. And so we have that constant turnover. People often will talk about thermogenesis, or how much when you eat, and protein has a higher thermogenic rate. If you read freshman nutrition, it'll say, well, it's because it's harder to digest and absorb. And that's not it at all. The issue is muscle protein turnover is a very expensive process. The other part, carbohydrate and fat, muscle is really a central part of metabolism of both carbohydrates and fat. So people who have insulin resistance begins in muscle. Muscle basically has a need for carbohydrates, but really only for high-end muscle performance. The basic fuel for muscle is actually fats. And so when we think about regulation of blood glucose and fatty acids, it all begins in muscle. If muscles are healthy, our chances of not having diabetes we're protected. If muscles are healthy, our blood lipids are more stable. Protein is really just sort of a food source of amino acids. It's kind of like a vitamin pill. We don't really have a need for the pill. We have a need for the 14 vitamins inside of it. And that's really what protein is. Protein is like a vitamin pill. It's simply a food source that delivers amino acids. There are 20 amino acids that we call naturally occurring that are in our food. And as you mentioned, 11 of them we can actually make. So if we get one amino acid, we could actually make a different one from it. But there are 9 that we actually have a daily requirement for, and we call those essential or indispensable. And of those, each of those have metabolic roles. We always think about, again, freshman nutrition, amino acids are building blocks for new protein, which is true, but they also have individually metabolic roles. And so an amino acid like leucine is directly used for the formation of carnitine, which directs fatty acid oxidation. Phenylalanine is the direct precursor to tyrosine, which is important for dopamine in the brain and cognitive function and memory. Tryptophan, serotonin for mood. All of these are very related to the amount you eat. So if you have a very low protein diet, all of these other functions, mood, cognitive function, memory, fatty acid oxidation, all of those are downplayed. Another one I like is threonine. 75% of the threonine in your diet goes for producing the mucin in the lining of your gut. So we talk about prebiotics and probiotics. Probably the most important one is threonine, which produces the protective lining. And then, my favorite, which I know you know, is leucine, which is a direct relationship for a signal to stimulate muscle protein synthesis. So there's lots of these metabolic roles. And I actually published 2 papers in the last year arguing it's time that we stop talking about protein. It's like saying we need a vitamin pill and start talking about the 9 essential amino acids, because that's what we actually need. And that then leads us into issues of all proteins aren't equal. Amino acids aren't equal in every protein. So.
And yesterday my son came home and he's about 13 years old, and he came home, he was in the worst mood. He was crabby, irritable, just like snapping at everything. And I said, "What did you eat today? Like, what did you have?" And I know he had gone out for lunch with his friends, and there was only carbohydrates. He had only had maybe there was a gram somewhere, accumulated of protein. I was like, "You sit down and you have some ground beef, and then we're going to talk." And literally within 25 minutes, he was back. I said, "Oh, my Andreas is back. Like my normal son, is back."
I can totally relate. My birthday was yesterday, and I must admit I did carbohydrate loading, and so I had to get my protein back balanced today.
Around the idea of nitrogen balance, and I'm saying this because the vast majority of people who listen to this show are women, typically perimenopausal and menopause. And one of the biggest challenges I find with my beautiful women is that we still have this hang up around somehow that meat or just a lot of protein is a very male centric effort. It's like man, fire, grill, barbecue, rather than, yes, it's also important for you as well. So can we talk briefly about nitrogen balance and how the maybe inefficiency of protein assembly changes with age? And we want to be thinking about not only the protein that we're taking in, but potentially also the protein that or I should say, maybe more accurately, the nitrogen that we're taking in, but also how we may be losing on the other end of nitrogen, like when we're thinking about nitrogen balance, like nitrogen in versus nitrogen out.
What we know is that early in life, our whole body development is very heavily driven by hormones, insulin, growth hormone, IGF-1. And so I started my career studying malnutrition in Africa. And we know that children can grow with really bad diets, without being, just absolutely deficient. They will still grow and develop, and we can reproduce. And that's probably all survival. But somewhere after age 30, we start getting into that aging phenomena. That's a vague, is it 30 or 40? I don't know. But by 40, we know that we begin to have a downward decline in certain metabolic aspects. And one of those is our rate of protein turnover. So I mentioned that we have to make 300 grams of protein per day, but as we get older, we get less efficient at that. And the older we get, the more inefficient we get. And so our ability to repair our body structures, if you sprain an ankle or break a bone, it takes a lot longer to repair that when you're 65 than it does when you're 16. And There's reasons for that are all metabolic. But one of the great discoveries by Bob Wolf and the Galveston group in the late 90s, sort of the same time we were discovering the leucine story, they discovered that basically, while there's a decrease in efficiency as we get older in protein turnover, if you give more protein, you can overcome it. So the capacity is still there. And so what we know in the aging process is that you don't need less protein. You actually need more protein and of a higher quality. So you need protein with more of those essential amino acids, and you need a higher amount of them. So nitrogen balanced protein, as we get older, those terms become more misleading because we sort of now are interacting with aging, and what we can do when we're 16 or 25, we can't do when we're 55 or 65. And so we need a different approach.
So the protein handling gets poorer, but you can overcome that by increasing your protein intake. And this is going to lead very beautifully into protein quality as well.
And that's really where the leucine story comes in. When you're 16, you're not really very sensitive to leucine. If you have a 10-gram meal of protein, you'll develop protein synthesis. If you have a 20-gram, you'll develop twice as much. When you're over 40, we know that a 10-gram meal, a 20-gram meal will have zero effect on muscle protein synthesis. The body is insensitive to it. And we know that you become more and more sensitive to the leucine amount in the meal to actually trigger protein synthesis. So, how we regulate as a 20-year-old is totally different than how we regulate after 40. The hormones aren't really driving it anymore. So insulin, growth hormone are still important. If you were totally devoid, that would be a big problem. But they're just really kind of baseline. They have to be there. It takes very little insulin to actually be involved in protein synthesis when you're older. But what we now know is the body then becomes totally sensitive to resistance exercise and the protein, and particularly a signal leucine. And we can go into a little more detail, but leucine is what we call a branch-chain amino acid, and there are 3 of them: leucine, valine, isoleucine. And those 3 are totally unique in that they're really only metabolized in skeletal muscle. All the other amino acids, the other 17, are metabolized mostly in the liver, but these 3 are only metabolized in the muscle. And so the muscle has evolved to recognize those as a meal signal. When you eat a meal, the muscle sees exactly how much leucine you ate, and when it reaches a certain threshold, it says, oh, okay, that meal was adequate. I can turn on protein synthesis. And so if you only have a 15-gram meal of protein, muscle won't see enough leucine to turn it on. Where if you have a 35-gram meal of protein, muscle will say, I've got enough protein to turn on this very expensive process of muscle protein synthesis. People need to understand that the body regulates liver synthesis of protein very differently. In the middle of night, when you're starving, the body has to be making liver proteins. If it stops, you die immediately. So where does the liver get its amino acids? Well, it gets it from muscle during the middle of the night. So muscle becomes what we call catabolic. And so we have to replace that every day. And the only way you replace it is having meals that have more than 30 grams of protein. So if you go through the day with very small meals of protein, you'll protect your liver, but your muscle will be continuously catabolic. And we think that's a huge issue of aging, particularly in adult women. We know that 40% of women over 60 actually are below the RDA, which is about 56 grams per day. That's extremely low 40%. And probably accounts for both muscle problems and bone problems in older women. Does a 70-year-old have a different need than a 50-year-old? We don't really know that. The research has been done. We know that there's a huge difference between a protein intake that supplies less than 2 grams of leucine and a protein intake that supplies 3 grams. We can tell the difference in that. But can we tell the difference between 3.0 and 3.1? Our methods aren't that sophisticated. So I think the general answer to your question is we know that the minimum threshold for leucine is around 2.5 in a 60-year-old. We tend to use the term 3 grams, which kind of addresses your issue. Does it go down some with aging? We say, well, you should really target 3 grams at a meal. And that kind of addresses it. But the reality is we can't really answer your question, but we suspect it probably goes down with aging. But there's so many other things going on. You need less total calories. A 70-year-old needs a lot less calories than a 50-year-old. So you have to have a higher nutrient density. There's just all kinds of things going on. And frankly, we haven't been able to study it that refined yet.
And this is also one of the reasons that I have really departed from the concept of fasting, particularly in the first half of the day. So you talked about this idea of the muscles literally feeding, becoming catabolic in order to feed the liver, in order to feed systemically the body.
Yeah.
And they will stay catabolic, sounds like, until you reach that sort of minimum required, minimum effective dose, let's say of 30 grams of protein or about 3 grams of leucine. And so for the women who are fasting, let's say until 12 o'clock, 1 o'clock, or even I would say the OMAD group, so like the one meal a day, you are waiting. Often it's, the meal a day happens in the evening. You are waiting so long, like your muscles have spent now 12 hours, 14 hours, 16 hours in this catabolic state. So the net result, I would assume, over time is that maybe you lose weight, but your body composition actually change. You become like a skinny fat. You become relatively fatter, even though maybe you've changed your absolute weight.
Yeah. So, we've done some studies, actually quite a few studies looking at weight loss. So you're talking about time restricted feeding or fasting, etc. I don't recommend fasting for anybody over 30 ever. So, 36, 48, 72-hour fasting, some people think that's somehow a cleanse. I think that is a muscle loss that is never recoverable in an older adult. So, a 25-year-old can pull that off, but a 65-year-old should never do that. Time restricted feeding as a strategy for calorie balance, my opinion is the more catabolic you are, the earlier that meal should be, just for the same points you're making. So you're coming out of the overnight fast. But if you're a daily exerciser who's doing resistance exercise and basically healthy and having a good protein level, if you want to consolidate that into 2 meals, I think that's okay. I never, I'm not a fan of 1 meal per day in older adults ever, but 2 meals, one at 11 and one at 7. I sometimes practice that, but I go to the gym every day. I do resistance exercise. So if you're more catabolic, for example, 75% of Americans are sedentary. They're catabolic most of the time. If you're trying to do weight loss, you're more catabolic. I think then your first meal should be as early as you wake up. You need to get out of that catabolic period as soon as possible because you're inherently catabolic anyway. So again, I think who you are kind of makes a difference. If you have a good protein intake, you're doing a lot of resistance exercise, and your first meal doesn't start till 11, I think you're perfectly fine. But if you're inherently trying to lose weight, you're inherently sedentary, you're 65, then you should be eating that protein within 30 minutes of waking up.
I would love for you to talk about the difference here in protein quality when we're talking about animal proteins versus plant-based proteins. And I'd love for you to talk about this, and you do so beautifully, around the bioavailability and absorptibility of some of these proteins and the differences sort of that lies within, like, between the two camps.
Yeah. So let's just start with animal proteins. So animal proteins, we've talked about the essential amino acids, those 9, and they're in very specific balances. We need about 1 gram of methionine. We need about 6 to 7 grams of leucine. We need 3 grams of lysine. So we need, just like we need specific, we need 60 milligrams of vitamin C. They're exact amounts. And importantly, all animal proteins, whether it's meats or dairies or eggs or fish, have exactly the right balance for humans. Not surprisingly, plants have exactly the right balance for plants. Plants make leaves and stems and roots and seeds and flowers, which are pretty different than brains and hearts and livers and limbs, arms. So people need to understand that the plants aren't making proteins, amino acids for us. They're making them for themselves. And so they're not in the right balance. And you'll see proteins like quinoa will often advertise that it has all the essential amino acids. Well, it does, but they're in totally the right balance. And to get enough leucine to actually trigger muscle protein synthesis would require about 7 cups of quinoa at a meal. I like to say, things like chili are a perfect kind of food. You can have a meat in it. You can have your beans in it. You can have vegetables, onions, green peppers, tomatoes, whatever. It's a perfect blend of all of the different foods, using both plant and animal foods to get the right balance. So the problem with plant is the amino acids are in the wrong balance. And then the other part of it, again, the amino acids are there for the plant. So about 50% of those proteins are attached to fiber. They're part of the structural part of the plant. And humans don't digest fiber. And so the amino acids or the proteins that are in the plant aren't available to us. So when we see something like a whole grain cereal that says it, just for easy numbers, let's say it says it has 10 grams of protein in a serving, it's probably only 40% available. The bioavailability of protein from wheat, gluten, is very poor, probably about 40%. And so instead of having 10 grams in that serving, it only has 4. So where animal proteins are 100% bioavailable, most plant proteins are somewhere between 40 and 60%. So when you see it has 10, at best, you're probably getting 5 out of it.
So if a 55-year-old or 45-year-old woman says, hey, I'm plant-based, I'm vegetarian, for whatever reason, whether it's an ethical or economical or whatever environmental reason that they don't want to be consuming meats or animal-based proteins, they would by necessity need to consume more calories in order to sort of equate with the same physiological or metabolical consequences that we're talking here in a 45 or 55-year-old woman who's consuming animal proteins, yes?
Right. So, we've looked at vegetarian and vegan type of meals. The average vegetarian in the US is about 65 grams per day. The average vegan's around 55. We've done some modeling of looking at essential amino acid needs. And what we know is that if you get below about 50% of your protein coming from animal protein, you can no longer meet your essential amino acid needs with a plant-based diet. So to your point, you have to increase both the total amount of protein, and that means the total calories. And so typically vegetarians and vegans decrease their protein when in fact they need to increase their total amount. So it's perfectly possible to be vegetarian or vegan, but you're going to have a lot of food knowledge about essential amino acids to balance that. You're going to have to either dramatically increase your calories or going to a lot of ultra-processed foods where you're using isolated proteins to help keep the calories down. The problem in most plant-based whether it's beans or seeds or nuts or whatever, your calorie ratio in beans and legumes, for example, you're going to get about 3 or 4 to 1 carb to protein ratio. So right. If you're trying to hit 100 grams of protein, you're going to get at least 300 grams of carbs, which is 1,200 calories just in carbohydrates. So there's just a lot of difficult problems, and it doesn't mean you can't do it, but it takes a lot of food knowledge and a lot of food skills to make that work. And again, the average adult in the US doesn't have either the knowledge or the food skills to pull that off. So recommending it blindly that we all should have more plant-based diets might sound good, but that's a route to very poor adult health. Soy protein isn't unto itself novel. If you eat it as edamame, the right. Bioavailability is only 60% or less. But if you do process it and isolate it out as a powder, a protein powder, then the bioavailability is up in the 90s. So now you have a powder that you can use, and you can make a shake or a product out of it. But again, you're now basically shifting from what we might say are natural foods to ultra-processed foods to make that work. So the two things I would recommend to vegetarians or vegans are they do need to bring in some plant powders, and they also need to be very conscious of resistance exercise. because their muscles are at risk because they're going to have a lower protein diet. And one of the ways you can increase the efficiency of the protein and also protect your muscles is with resistance exercise. So two things I always recommend is, you need to be physically active, you need resistance exercise, you probably need powders. And that's one of the reasons that most vegetarians are under the age of 40. The average vegetarian in the United States is between 20 and 40. Why? Because it's easier to be physically active and have these other products and eat more calories. It's very difficult for a 65-year-old to be vegan.
It's also illegal, I think, to raise your children as vegan. I think you are not allowed to do that because you run the risk of malnutrition.
I mean, it
and
should be,
stunted
but it's
growth.
not in the United States, unfortunately.
Yeah. I have heard of, I know in the UK there was, I think there was a child who died of malnutrition, and the government, or, the country, I guess it would be the government, ended up suing them for child neglect, because
Yeah.
you have to give children.
Yeah, I mentioned early in my career, I worked in Africa in childhood malnutrition. And one of
Yeah.
the things we saw was, children will survive on very poor diets, but they have very low muscle mass. And what that means is it predestines them to be obese. If you don't develop your muscle mass in your, up to through your 25, 30 age, you can't develop it very well. It puts some limits on the maximum muscle mass you can get. And that's what I think you sort of alluded to it early. It's sort of skinny fat. And that's what we see in a country like India, where basically, I think they're number 2 in the world in diabetes. But if you look at them, they all look fairly thin. And it's because they have almost no muscle mass. So they're what we call skinny fat. So they're extremely low in muscle, they're metabolically challenged, and they're very prone to insulin resistance and diabetes.
There's documented evidence of this when the Germans had, I think they had bombed, was it the Netherlands? And then they had sort of not allowed food to get into the country for whatever reason. There was some retaliation. I don't know the details of that. But that winter, there were so many, the women who were pregnant at that time ended up giving birth to these children who, so the mother didn't get enough protein, the mother didn't get enough total calories, and with that, of course, total protein. And then their children, once those children were born, if they survived, all became obese, like without any, like 100% of them became obese. And so they followed this sort of cohort of individuals over the course of their lives, and they always struggled with that. So what you're saying here, I think, if I'm summarizing it, and redirect me if I'm incorrect here, is even though in our youth we are driven more by insulin and IGF-1, if you still don't meet a minimum requirement of protein intake, you are basically setting yourself up for sarcopenia and obesity together.
Yeah, exactly. And again, their malnutrition in Africa, I think you're referring to the Stalingrad studies in Russia that came out of World War II. We see it in India. So we see it around the world that, if you don't develop it correctly as a child, you go through those critical growth periods, you can always add some muscle later in life, but you're always limited sort of by your DNA. We call them satellite cells. Your DNA and muscle will always limit you. And I did some early studies that were animal studies during my PhD, actually, and we sort of demonstrated that there are critical growth periods. And if you don't establish that muscle potential, you're basically stuck with it for the rest of your life. I first got interested in leucine way back in graduate school when I realized it wasn't metabolized in liver. Okay, so that tells us something right away about mTOR. So the body has evolved to send leucine out to muscle as a specific muscle signal. If we look at mTOR, mTOR responds to a lot of different signals. It responds to insulin. It responds to carbohydrates, energy through something called AMP kinase. It responds to leucine, and it responds to exercise, particularly resistance exercise. So what that tells us is that the regulation of mTOR is different in different tissues. In the liver, it responds to insulin. In the pancreas, it responds to insulin. In cancer cells, it responds to insulin, but in muscle, it responds to leucine. And so the folks like Longo, who have looked at longevity, basically have used rodents, which continuously eat 24 hours a day. You can wake up a mouse or a rat in the middle of the night and look at the stomach contents, and it will have just eaten. It's absorptive 24 hours a day. But as we were talking about earlier, humans actually eat at night and then go through a long fasting period. When you allow the animal models to eat continuously, what you do is activate insulin continuously.
All the time.
And that triggers mTOR in all of the tissues you don't want to trigger it in. But when you convert them to meal eating, like humans do, now what you do is you only trigger mTOR associated with meals, and it turns on and off. And so the issue is the worst case scenario, and this kind of gets back to vegetarians, eating lots of small meals all day long is the worst thing you could possibly do for mTOR. What we want to do is have protein meals, probably 3 per day, where we turn it on and then let it turn off. Now we're doing the best we can for protecting muscle, which we know is probably the single most important thing for longevity. And we're trying to keep it shut off in the other tissues, so where it's not important. What we've done some actual cancer studies, and we know that insulin is a far bigger risk. Carbohydrates are a far bigger risk for tumor promotion than protein is. So again, if you're motivated by bias, which Longo is, you basically will tell one story, but if we actually look at the balance, we know that higher protein, lower carb is actually the better way to go for longevity, body composition, and muscle health.
And I think expanding on that, insulin, when you are activating mTOR via insulin, which is carbohydrate consumption, this is more of a systemic activation, where it sounds like when we are activating mTOR in the muscle, obviously we have muscles all over the body, but it is one specific organ, an aggregate of muscles through the body. It's specific to muscle tissue.
Exactly. And it's becomes more specific as we get older. When we're 16 or 20, insulin is still a fairly big activator in skeletal muscle. But once we stop growing, we know that if you look at age 10 to age 20, to have insulin stimulate muscle protein synthesis, it would take 4 times as much insulin to do it. We all become insulin resistant as we get older. People think of insulin as some major regulator, but the reality is insulin is a safeguard for adults. If the body gets exposed to too much blood sugar, we have to rely on insulin to get it back down. Insulin doesn't regulate our blood sugar. It's a safeguard against excess. And if we continuously challenge that excess, that's what causes insulin resistance. If we expose the body to too much sugar, blood glucose, day after day after day, muscle basically becomes insensitive. Glucose is, in fact, toxic in the body. We have to have it, but the body has a very real limit to it. The brain needs it, the red blood cells need it, but basically beyond that, we have very little way of getting rid of it other than extreme exercise. And so the muscles become insensitive, blood glucose goes up, and that's what is diabetes. Blood glucose, carbohydrates are something the body regulates very carefully, and it has its own disease, diabetes. I don't know of any good data that protein ahead of exercise is useful. There's one study by Kevin Tipton. We've done studies with rats and humans. We see no benefit of protein ahead of time. The body goes through a catabolic period during exercise, whether you have it ahead of time or not. So contrary to what a lot of trainers believe, I see no benefit at all ahead of time. I think there may be satiety. So now we ask, how far ahead? What's your pregame meal going to look like? I think having protein at a pregame meal 2 hours ahead helps you feel good, helps you have energy, but it's not going to protect your muscle. Okay. So there's different reasons to have protein. Protein after exercise, we're guilty of actually starting this nonsense. What we know is that with extreme exercise, muscle becomes catabolic. And so we use that model to actually discover the leucine mTOR. So protein synthesis is regulated at two distinct levels. One is what we call transcriptional, which is gene level, and that's where your hormones come in. That's what testosterone and estrogen do. They regulate the amount of RNA you have. They regulate your capacity, where diet actually regulates more of what we call the translational level, and that's leucine and mTOR, meal to meal. Okay, so what we wanted to do was create a catabolic condition that we knew only affected the translational level, the mTOR level, and not the gene level. So we did our first experiments were an hour plus of intense exercise, and we created a catabolic period that downregulated protein synthesis. And we showed then that the body stayed that way until you ate protein. And so everybody jumped on that and said, well, you should have protein right after exercise for recovery. And people, Halazi and others had always said you need carbohydrates for recovery too. So that's all true. The issue we now know is that the protein after exercise really only is critical in an untrained individual. If the person is well trained, you really don't go through a catabolic period. If you're going out and you're training, every day and you're running 10 miles getting ready for a marathon, and then you go out the day of your marathon and run 26, you're going to be catabolic. So you probably would get a benefit having protein soon after. But if you go to the gym and you're working out for an hour every day, doing exactly the same thing, it doesn't matter when your next meal is, whether it's 30 minutes later or 2 hours later, you're going to get the same benefit. So the whole idea of having protein timed exactly before or after exercise, I think people need to understand that that is an untrained maximum performance, one-time acute effect. That's not routine. So I sort of downplay the timing around protein. I think that distributing it as 3 meals a day, maybe some athletes want to go for 4 meals a day, 4 to 5 hour intervals. I think that's great. Someplace in there you fit in your exercise, and chances are that exercise is within 2 hours of the next meal. I think that's fine. So these guys who are carrying protein supplements into the gym and chugging them on the way out are wasting money.
Wasting money. So, and that's because the muscle is still going to be catabolic. If you are moving the muscle, if you're training the muscle close to muscle failure, the muscle is still breaking down. So you are not going to prevent that.
Having protein ahead of time makes no sense. Having it afterwards, I think it's fine. But whether you have it 30 minutes afterwards or 2 hours, you're going to get the same net effect.
So someone who's been training for longer than a year,
I would say really 4 months. Someone who's doing basically the same training, they're skilled at it. It's no longer exhaustive. They can do it. It's pretty comfortable. So, a kid doing, football practice after the first week of being sore, you're basically trained. So there's no more benefit. During that first 2 weeks of fall football practice or soccer practice, having protein, there may be benefit to that. I don't have a problem with that. But again, these guys who are going to the gym every day, day in, day out, and buying expensive protein supplements, they're not getting a benefit from that.